I'm extremely excited about like the advancements that we're making on like those key pillars, the process AI, the data enrichment, and the knowledge. Because I really think that those are going to be linchpins in how we make things in America. I really see a sea change in the industry because, like you brought up, like the American dynamism at the forefront, everyone now understands how important manufacturing is as an economic engine for the whole country and from like a national security perspective or just stability perspective. We all remember when we couldn't get stuff during the pandemic. And so just further like advancing manufacturing in a positive way in the national conversation is something I'm extremely excited about because not enough people know how rewarding and cool it is to work on really big industrial stuff. And I think it's one of the biggest joys in my life that I've been able to, attract amazing talent who otherwise wouldn't work on manufacturing, who now do. They love it and stay for a really long time. So there must be something to it.
Welcome to Sorcery. I'm Molly O'Shea, the founder of Sorcery, a weekly top VC deals newsletter and now podcast highlighting the top GPs, founders, and deal announcements leading the next innovation cycle. Today, we have Willem Sundblad, co-founder and CEO of Oden Technologies, an intelligent industrial automation company empowering manufacturers to embrace next-gen technology and achieve perfect production. Oden just raised a $28.5 million Series B to provide complete visibility into all of the production processes in real time and deliver instantaneous insights leading to effective quality control, timely maintenance, lower machine downtimes, optimized operations, and higher customer satisfaction. I hope you enjoy this conversation. Hi, Willem. Thanks for joining us.
Thank you so much for having me.
Well, congratulations on your big round. Would love to learn more about it.
Thank you. Yeah, it's exciting times. The total round is 28.5 million, but that includes part debt facility, a little bit of convertible note, but the biggest portion is newly issued equity. So the lead was, this is going to be a Swedish word, so it might not go that well for Americans, but Nordstjernan Growth. For the purpose of this, we can call them Northstar because that's how it translates into English. But it's a great firm. Originally, Northstar is one of Sweden's biggest industrialist families that have been around for hundreds of years. They've owned industrial companies for a real long time. And they started a growth fund focused on software companies a couple of years ago. So this is coming out of Northstar Growth. So long-term investors and really excited about having them supporting us on this journey.
How'd you get connected to them and what was the composition of the round? Was it mostly institutional? Was it strategic?
A little bit of both. Originally, they actually reached out to me 4 or 5 years ago from the kind of industrial side because they wanted to just learn about new advancements of manufacturing technology, data and AI in manufacturing. So I just built a relationship with them of just giving advice to the industrial side. And then when they started the growth fund, started a discussion there. And it wasn't really until August last year when I reached out and said, hey, I think we're at the point where we're going to do a round. Are you interested in looking at this? And that's when conversations really started. So in total, they were the lead. But we also had customers who invested. We also had Flat Capital, which is the investment company of the Klarna CEO, and another partner, recurring capital partner, who also came in. And pretty much all existing investor had participated in a note prior to that converted into this round as well. So mainly institutional and a mix of new and old, which keeps things fresh.
Got to keep it fresh. Well, to go to the beginning of it all, how did you become so interested in manufacturing and efficiency? And was there a specific process that you set out to improve with Oden?
So originally, I've always grown up around manufacturing. Originally from Sweden. My dad was always in manufacturing. I remember growing up visiting factory floors wherever he worked with him. Actually, my dad, my grandfather, and great grandfather all started on the same factory floor in northern Sweden in the paper and pulp industry. And I've always loved making things. So I went to school for industrial engineering, specialized in production in Sweden and France. And it was actually a professor of mine who sent me around to manufacturing companies in Sweden to interview them how they do analytics and optimization. And this was in 2011. And like big data and like advertising technology was getting hyped. And I kind of saw the dearth of technology that people were working with in manufacturing. It was Excel at best. And I thought it was crazy that so much, brain power from these amazing engineers and so much of this technology was being applied to get us to optimize ads instead of helping us make things. So I got really consumed by the idea that you can take kind of a production function of how you would make a product, turn it into a mathematical function and understand at least how to never make a bad product. So how can we predict and understand the quality of the process? And then within that, dynamically optimize it based on current constraints. Because a manufacturing environment is almost like a living organism. You've got variables that change all the time. You've got, one day they're optimizing for making things as fast as possible. One day they're optimizing to make it as cheaply as possible. You've got suppliers that change, materials that change, product specs that change. So you need to be able to dynamically optimize it constantly. And that idea really stuck with me from 2011. But I've always just had the sense that like manufacturing is extremely important. And if we can make it efficiently, we can make it close to where it should be consumed. And we shouldn't just be shipping it off to wherever it's cheapest in the world.
Right. Is there a specific vertical within manufacturing that you go after? How did you set out on your current customer set, and where are you looking to expand it to?
Yep, absolutely. I'd say right now, you can kind of think of our industries, they tend to be what I call operator dependent. To give some specific examples, paper and pulp is a big one, extrusion or plastic extrusion, or a lot of plastics processing in general, chemical mixing. You can kind of think of manufacturing as two ends of the spectrum. You've got the most discrete processes in the world where you make, individual units like a circuit board. You've got continuous processes like oil and gas or like petrochemical processing. We tend to fit somewhere in the middle, where it's kind of batch continuous manufacturing, where you've got a product mix, you've got a process that you want to optimize, and you've got high variability in the process, in the product mix as well. In a lot of these industries, if we take paper and pulp as an example, you've got huge cost of quality. And you tend to have a pretty long lead time on knowing whether what you made was good or bad, because you take samples, you run it to a lab, you find out hours later whether it was good or bad. So you end up in a situation where things are definitely running, and they're running well, but they're not running as well as they can. And especially you end up with a lot of variance in how different operators are doing things. And in that variance, you can find a lot of insights about how you can tweak the process. So typically, within these types of, complex processes, we can predict quality and prescribe new machine learning generated settings to operators to get all of them to do things more consistently in a better way. It's like all of these industries, whether it's paper and pulp, plastic extrusion, or chemicals, almost all of them say that it's more of an art than a science to run the process. And I used to always say that we are trying to add science to it, but I've come to the realization that it's way more effective to say that we want to make it easier to become artists for these operators, because they are really amazing and they got so much domain knowledge, but it's just so hard to learn and the turnover is crazy. So if we can give these operators and these processes the right tools, we can change the nature of those jobs, change the nature of those companies, and just be more effective and efficient across the board.
What do you mean when you say the turnover is crazy?
Mm-hmm. So oftentimes, like a ramp period for a new operator is at least 3 months. And they very often have like a 50% success rate of that training program, and that 50% even end up starting the job in the first place. A lot of them have 70% year-over-year turnover on the factory floor were at least 70% if you look at it on a 24-month cycle. So you often end up in a situation where for a manufacturer, you have one cohort of staff that have been there for 15 to 40 years, and you have another cohort that is just cycling through. Because the jobs are really tough, and it's especially really hard to learn. And that type of environment is very stressful. And there are fantastic careers in manufacturing if you stick it through, but we want to make it easier for people to have that whole journey. But turnover is crazy. And not only turnover, most of these jobs are just unfilled right now.
Could you unpack a little bit more what the day-to-day role is so people have a better understanding of what's going on inside a manufacturing facility and what people are trying to ultimately get onboarded into and then run?
Absolutely. Like at the highest level, a day on a manufacturing floor should all be the same, but they never are. I've heard customers always say that it's a little bit like Groundhog Day. Every day there's something different. Like it should be the same, but everything is a little bit different. And you tend to have, engineers that are there to solve big problems, make big improvements, new initiatives, and you have operations that are trying to get the, trains to run on time. And that's everything from a plant manager who's got the kind of helicopter view of the facility down to the operators who are, where the rubber meets the road on the line. And so they have work orders that they're going to run of different products that they're going to make. And they tend to have on a given line, maybe 5 to 15 different machines from different machine makers that they need to coordinate in order to make that product. And in the best case example, it just runs and they make things the same way all the time. But that isn't really the case because the lines are probably different. One of them got replacement part that changes some of the dynamics than another one. And so you end up with every product or every SKU, in order to be done as well as possible, needs to be done differently on each line. Like some of them can run at 1,500 feet per minute, others can only run at 1,400. And learning all of these different permutations of how to run things as optimally as possible is really difficult for these operators. And also then you have to learn the actual domain knowledge of the process itself. Because if we take plastic extrusion as an example, there's a rhyme or reason to how you should go in and actually change the variables. Typically, you start up a run, you're just trying to get it within quality specifications, which means that the zone temperature of the extruder needs to be set just right to get the right melt flow of the material. You need to get the tolerances on the dimensions just right to be within the specs of what the customers are expecting. After that, you want to make it as fast as possible. So you want to increase your line speed and your motor RPM in order to get the material to flow in the consistent way in lockstep. And everyone does all of this slightly differently. And since there is so much variation in all of this, by the nature of the job and nature of the different machines, the different products, that's the type of variation that our models really love to see, because we can then find what is the right combination of metrics, what is the right order of operations to do things, and give these operators not only like the comfort that you're doing things right now because you're getting a prediction of the quality, so you don't have to be nervous about messing up, but also these recommendations give them kind of a cheat sheet on performance. Like your speed should be this, your RPM should be this, you should ramp that up until it stabilizes, then you should go and change these other things.
That's a really good transition into Process AI, your product. So let's dive deeper into that. What is Process AI and how did you get to the current version of this product, and how have you shared it within your current customers?
So a lot of iteration. Originally, we started off looking at the data problem in the manufacturing itself, because that is a really interesting problem. You have millions of data points per production line per day that is being generated, and a completely arbitrary number of context intervals that needs to be associated with it. as an example, what operators on the line, what product are you making, from with material, what type of material, from what supplier. And so it's a very complex data picture. And once we got into predictive quality as like the key problem we wanted to solve, because we just saw that the feedback loop of you make something and you find out way later if it's good or bad was such an interesting problem. As soon as we could predict quality accurately in real time, the next question was from the customers, okay, well, how do I use this? And especially if you're telling me that you can, based on my inputs now, tell me what the output is. If I tell you what output I want, can you tell me what inputs I should have? And that was kind of a starting genesis of process AI, because we went through many iterations before it really took off. And the thing that really made it fly was that we managed to make it extremely simple for the operator themselves so that they can make better decisions in real time. And it's a combination of both that type of seeing the prediction of the quality. And so in paper processing, that might be things like the strength characteristics of the paper. Or in other industries, it might be wall thickness of whatever product you're making, or some form of dimensional characteristics that are hard to measure as you're making it. And so predicting that in real time to change the feedback loop for operators, so that when they make a change and they see it, they know that they're not messing up, so their stress level is lower. But the second piece, on the recommendation side, has really changed kind of the value and the adoption by operators. And so today, if you look at kind of back to that original idea of let's take the production function for how we make a product and understand all the potential settings that we could use to never make a bad product, and you plot it on like cost on one axis and throughput on the other axis, current performance by operators will be a very big scatter plot. And so process AI, when we give them the recommendations that have a good trade-off between profitability and risk, that whole scatter plot moves to a much, much tighter grouping. So to give you an example, we had one customer where the target for how they should be making a product was somewhere around like 500. Their average performance was like 350, just because all the operators were doing things completely differently. And that's for the same product on the same line. Through process AI, we managed to get that average up to 560. So that's 10% above the target, but especially we just got everyone up there. And it went from being, something that they were experimenting with predictions and recommendations to just being used between 80 and 100% of all runtime. Because it's just, the operators know that if I do this, I'm going to make it right, the quality is going to be good, and I don't have to think about the variables themselves, because they got so many other things that they need to do that we're kind of just making it easier for them.
Yeah, you talked about this a little bit in the beginning, but I'm curious, for such a legacy industry, I can imagine it's hard to sell into. It's hard to offer new technology. I'm sure they're getting sold things left and right, and they might just not trust it because they've been running these businesses for tens, if not 20, 50 years, right?
Yeah.
So how do you get them comfortable with using a new kind of product like this, and what is the onboarding process with their teams?
Great question. I think that manufacturing is famously hard to sell into. I would argue that it is extremely rewarding to sell into because they make decisions over the long term. And so once you're in, you are in for a really long time. You end up building amazing relationships over many, many years. And especially when you deliver for them, it's gonna sound corny, but you got a friend for life. Because they really are just, they're fantastic people to work with. I think people often say that you have really long sales cycles in manufacturing. And we've found that that's not necessarily true. If you have a long sales cycle, it's because they're doing something else that's more important at that time. we found that you either have a short sales cycle or you're kidding yourself that you're in a sales cycle because they're busy doing a lot of other stuff. So we found it to be way more effective if we just focus on the ones that are actually going to buy, that are, wanting to spend money on the problem that we're solving today. And instead of having a 12 to 18 month sales cycle, you have a 4 to 6 month sales cycle. And everyone's happier because we're not pestering the people who aren't going to buy in 12 to 18 months anyways. And I think in the past, when we were looking more at the kind of high level data problem, it was definitely harder to get people to understand how the roles were going to change or where the value was going to come from or what the magnitude of that value was going to be. But with Process AI, all of that's kind of baked into the product. You can, with one screen, just show them what the differentiation is, what they're going to do with it, and what the value is. And so showing that to a manufacturer has in more cases than not, just been met with open eyes of like, you can do this. And I know especially the thing that's just top of mind for all of these manufacturers is like the labor challenge. How do I get my people to get onboarded faster? How do I capture the domain knowledge of the great people who've been there for 30 years and distribute it to everyone else so that everyone you kind of raise the bar for everyone? And so I think to sell into manufacturing, you can't be bullshitting. You have to be very specific with, this is the problem we're going to solve. We're going to deliver, in this case, Process AI. You're going to have these metrics on that screen. It's going to predict these quality scores. This is the current variance of your manufacturing process right now. Here are 5 case studies of where we've reduced that variance with 1 or 2 standard deviations, so that there's a lot of trust ultimately. We try to architect that in the contracts themselves too. Typical deployment might be 2 months, and we ensure that there are appropriate opt-out gates, even if they sign up for a 12-month or a 2-year agreement right out of the gate. There's usually some form of risk mitigation where we just say, hey, if this doesn't work, you can pull the plug and we'll give you the money back. It's never happened, but I think it's often gives people comfort, and it's a show of confidence from us that we just tell people that, and we mean it, but it just hasn't happened.
Yeah, it's important to instill that trust and have those relationship expectations set beforehand, because unfortunately we're in a world of sleazy salesmen who might sell you one thing that might not be true. But
and that does not fly in manufacturing. And I think one key thing in that whole journey is there's a statistical validation and testing of when it's first launched that is important to win over skeptics. But the main thing that changes is when they use it and it works and it just becomes part of day to day. We've found that there's an installation process, and then there's a validation process. And in that validation process, you might look at the statistical significance of the accuracy of the quality tests compared to our predictions compared to what their lab is actually testing. And that's important. But then they actually just go and make changes. They're like, okay, well, if I increase my speed by 10 feet per minute, I expect that the quality score is going to suffer. And so they make that tweak, they see the prediction change, and then they see the test results a couple of hours later. And as long as that whole loop works too, then you start getting into the true intuitive trust in these metrics. And we also we bias towards machine learning models that are interpretable. So we can give them the whole weights and coefficients of the model for the predictions. So when we predict a strength characteristics in the paper process, we look at all of the variables that went into that process, and we actually give them, this is how much the refiner energy impacts this quality test. This is how much your speed impacts this. This is how much these chemical additives or the starch flow, all of that is given to them so that they can, again, just build further trust in it.
Right. And I'm curious, so Are there specific manufacturing processes? I know you've mentioned a couple. Are there specific manufacturing processes or industries that Oden is particularly well suited to address? And if so, could you share more examples of that?
Yeah, it's really the ones that are kind of operator dependent. So like paper and pulp is a fantastic one. Really all types of plastics processing, like compounding of the actual material itself, extrusion, which is how you make anything that's long out of plastics. That includes wire and cable, packaging, building products. We've started doing more and more in metals, so like metal drawing and different types of casting processes. It tends to be a lot about how the data behaves in the process, because at the highest level, manufacturers care about the same thing. They want to know utilization of machines, performance of machines, quality of the process, material consumption, and maybe some other efficiency metrics. And then underneath that kind of high level, we all care about the same thing. They have different like metrics associated with achieving those results. And so there are industries that are more discrete in nature, where like the data can be difficult to track from one step to the process, from one step to another. That makes it difficult for us to really show value on the whole stage. So that's why we tend to bias more towards kind of continuous, batch continuous processes. Because that's where we have a lot of variance, a lot of cost of quality as well. Oftentimes, it's also like the machine landscape needs to be pretty fragmented. Like if you had an industrial process where it was just one machine and that machine does all of the output, like a jet engine or like an elevator in a building. In those cases, the machine makers themselves tend to do it in a vertically integrated way. But in all of our industries, yours tends to be multiple machines on one line that are integrated into like a distributed control system. And then you have like an ERP system and a quality system. So there ends up being 5 different data sources that are all integrated in order to make it work.
Yeah, that
You look
seems.
scared.
I mean, that seems super complex. I've had a lot of vertically integrated manufacturing companies on the podcast before, like Varda, like
Yeah.
Hadrian.
So they're taking, the full stack approach, which if you had a blank slate, I think most of our customers would like to do that. But practically speaking, they don't. They have incredible capital investments already made, a lot of people, a lot of processes, and a lot of systems that are already in place. So we are trying to retrofit some of that orchestration and harmonization across these systems for them. But it is a good point, though. It's not for everyone, because we, it's almost like for a lot of these manufacturers where we've found our biggest fit are with the large ones, like $1 billion plus in revenue, because you have to have passed some form of bottom of Maslow's pyramid of needs, where there is an ERP system, there tends to be an MES system, manufacturing execution system, there tends to be an OT network where the data from the machines are flowing to one place so that our integration points are minimized. And also by being vertically focused on a couple of key verticals, you end up with a lot more standardization on like the technology that we're integrating with. So like if you go after paper as one industry, they tend to look very similar and they tend to have, less variance across the systems than if you just say we do all of manufacturing.
Yeah, it's that's a lot. And I'm curious from like a size perspective of your customer set, how many manufacturers like this are there in the United States? Do you have any customers outside of the US, or do you have plans to grow outside of the US? If you don't, what does that current size of the market look like?
So right now I'm going to use like the plastics industry as an example, because that's probably where I have the most accurate data for it. So you'd have about 16,000 factories in the US in the plastics industry alone. Out of those, and Europe is about the same, Asia is about the size of US and Europe combined. Out of those 16,000 factories, about 60% of them are SMBs. And so the ones we're targeting fit into the like 40% category, because the majority of factories in the US as a whole are mom and pop, small small businesses. But within the enterprise category, there's still a tremendous amount of both number of accounts and number of factories that they have. But we're definitely not a volume player. We sign big customers and big multi-year deals, and that's how we make our business work. Right now, we're mainly doing outbound and have staff in the US and focused on North America, including Canada and Mexico. We have customers that are in the process of rolling us out to Europe and Latin America also. I think the next step is going to be more outbound and boots on the ground in Europe. And that is most likely not for this year, but probably for next year. Again, kind of leading with the customers here that are expanding us and then following on with outbound.
Well, that's exciting.
Yeah.
Lots to grow. In my research on you and the company, I came across an interview you did where you were talking about a survey from 2023. So you surveyed around 300 manufacturing leaders on topics like labor, inflation, demand changes, and investing in sustainability. Did you have any particular findings from that you've reflected on in the last year that have really proven to be true and have informed your opinion on the growth of the company and what you're going to be providing for customers?
I think the labor one is the main one. I mean, we've been around for quite a while, and the labor issue was always a kind of frog in boiling water issue. From 2014, 2015, when we started talking to customers, it was always an issue that they knew about, but it never became a big enough pain point that they had to act now. The pandemic changed that. I think that changed people's expectations of jobs. I think the competition for labor went elsewhere. I think the biggest problem for manufacturers when it comes to labor is that people are leaving the manufacturing industry as a whole. They might be going to work at an Amazon warehouse instead of in operations. And so I think the labor one is the most consistent theme that we've seen in our kind of state of the manufacturing service. Everything else is kind of cyclical, whether it's sales constraint or production constraint. And we've seen insane cycles between 2019, 2021, 2022, and now again. I think I saw last month, this was the first time in a couple of years that the a supplier index in manufacturing went above 50, where they're actually seeing, things are starting to go in the right direction. But that hasn't actually been bad for us, because whether you're trying to make things faster or you're trying to make things cheaper, we can it's almost been better if they've been trying to cut costs. Because when they're so production constrained that all they need to do is make as much as possible, they don't have time to take meetings. They don't have time to do deployments. And they know that it's cyclical themselves. So in downturns, they try to okay, well, let's make these improvements that we didn't have last time, because it's probably going to come back again.
Yeah. Well, labor is a huge problem in the country. In the last year, this whole movement of American Dynamism and that kind of thing has really reshaped the narrative on American industry and what are kind of fun jobs or cool jobs to have. We're reshoring, we're doing a lot in terms of making sure that we have our own backs in case something happens, right? We're thinking for the long term. We're thinking for the 20-year horizon.
Yeah.
And Catherine Boyle of Andreessen Horowitz coined that term, American Dynamism, about 2 years ago. So it's been pretty active, and there's been a lot of startups and investors in the space since then, as well as OpenAI has taken off, and the AI boom has really become a thing that's a household conversation.
Yeah.
Those two things together, you founded the company around 10 years ago. So you were kind of ahead of the media curve on that, right? Because there's a media narrative that comes along with it. And B, the actual technological narrative, because you've been building your models and you have been deploying these products in-house. So because of those kind of macro components, how has that changed since you've started the company? How have you felt changes, and what does it feel like growing a business now versus, let's say like even 2 years ago?
It's night and day. I'm extremely happy that we were stubborn enough to, continue through it until things started, really picking up. And it's obviously not all tailwinds. I think it's just a classic tale of product market fit also. Like we were stubborn enough to iterate long enough to where we found something that actually took off. And we needed to make something that was, 10x better, that was simple and easy to explain and had a lot of value. And it took a long time to really get there. But on top of that, I remember because my co-founder and I, we were in Europe when we started the business. I'm from Sweden originally, and we thought we'd focus on Europe. And there's always been kind of a difference in culture between US and Europe. And I remember we had our first customer who's still a customer with us today. They're an amazing, amazing business. And we had told them what we wanted to do on a PowerPoint. And they just said, if you can do this, we'll pay you when you can do it. And then we went to a trade show in Germany, and I'm probably going to make a lot of Germans angry now, but that's fine. But this was in like 2014, 15. And we told them what we were going to do. And they just shook their head and said, like, you're going to put my data in the cloud? Never. And that was actually one of the big catalysts for us in moving here, and just said, screw it. If we're going to make it anywhere, we need to do it in the US. Like the culture is right. People are going to, the market is just so much bigger. They move faster. Customers are bigger. It was still like very much knocking on doors of manufacturers in 2015, 16, and those early days, talking about data, machine learning, and AI was still like met with a lot of skepticism until you could actually show very tangible things. So we're going to help your operators know what motor RPM and speed ratio they're going to use in order to have the right melt pressure profile. Like they're not excited about a term. And I think now there's an interesting dynamic where executives across all these manufacturing organizations know that they need to transform desperately, both from a technology perspective that they might be afraid of, and from a labor perspective that they are hurting from today. And so if you then come with a message that kind of straddles both of those things, that you can both say, hey, here's tangibly what we're going to do for the people today, and here's how this fits with the overall narrative that you hear about, it really changes the game. A lot of doors are open in a way that they never were. And a lot of people that we met in 2016, 17, and 18 are coming back now because they're like, oh, I understand what you were talking about.
So have you seen an acceleration in adoption for Oden because of that?
100%. We have, we've had exceptionally strong growth, even doing, like austerity times before we closed the round. I think, from summer of 2022 until we closed the round early in Q1, we had well over 3x growth while, having burn rate to the point where it was going to go away completely, increased margin, and essentially not adding to the team. And even with very limited investments, we've managed to have, stronger pipeline than we've ever had. And I think this is where like it's always hard to separate like how much of that is just timing and tailwind, how much of that is just a lot of hard product work and a lot of hard communication work and a lot of hard work across the whole team. But all I can say is it's probably just a perfect storm of everything. Like we worked hard enough to where the timing ended up being right, even if it was way too early in the beginning.
Gotta love a perfect storm. So with this Series B funding, what are you going to be investing in for yourself with the company? Like what are you going to be growing?
A lot of exciting things. I think like I'd put it in a couple of different categories. One category is just scaling process AI. And that means investing in the team and iteration on, continuing to iterate and advance that technology, but also in the delivery capability, the speed at which we can deliver it, the amount of recommendations we have available, the value of those recommendations, and just go to market for it. The other categories that we're really focused on are what we call data enrichment. So how we actually use machine learning to fix some of the inherent problems with manufacturing data. And I can give a specific example, because since you're tying in data from multiple systems, those systems don't really have an accurate view of the world. And especially some of them might come from manual entry. So like you have one system that is reporting the raw values coming from the machines. And you have another system where an operator is saying what is happening. Like I started product X at time A, and I started product Y at time B. And every operator does that differently with like a variance of 5 to 30 minutes. And so if you just take that data, combine it with the time series data, it's garbage. Instead of having the operator do that, which is a non-value added task for the operator, we can have an inference model that actually sets the correct start time, the correct end time, and the correct label. So you've just cut out something that the operators don't have to do, and you've increased the accuracy of the data by 80%. So those types of data, like using machine learning to classify and label the manufacturing data. Because then once you have accurate labeled data, a lot of the other things become a lot easier, and adoption by operators become a lot easier. The other thing that we're really focused on, and this is something that I'm very excited to launch later this year, is taking process AI to the next level when it comes to the domain knowledge. Because today, if you look at a demo, or if you go to the website and do kind of the interactive demo, it's numerical. Like we can tell you change, this, change the temperature from X to Y, change the speed from A to B, change the material flow from 1 to 3, but it doesn't necessarily tell you how to do that. And there's still a tremendous amount of domain knowledge that goes into that. And so actually using, it isn't really generative AI because we're not really generating completely new text. I look at it more of a semantic search exercise where we can actually take the domain knowledge from like textbooks of processes, from work instructions of how they should execute these types of changes, and build that into almost like a foundation model for a specific industry. And I use foundation model liberally, like not Mistral or anything, but like really a specific model for paper making as an example. Because then you can take the numerical recommendations, provide all of the context of like a really senior operator so that anyone on the line can go execute as good as the best ones. So I think that's where like manufacturing is losing a lot of jobs to, like, let's take an Amazon warehouse as an example. That job is easy comparatively because there's not a lot of domain knowledge that you need to know. You might get $30 an hour, which is a great salary, and you can have a flexible schedule. Within manufacturing, the salaries might be a variance between like 18 at the low end when you're starting off to like 36 at the high end when you've really learned all of it. And so, but it's also a 12-hour shift, which is difficult, and you need to earn your stripes in order to get it to the day shift. If we can make those jobs easier so that you can increase the talent pool of people who can execute them, and you can make transitions less with less risk, you can probably have more dynamic scheduling. You can probably afford to pay people 30 or close to 36 if they're performing on the 36 level much faster. So those things, especially like scaling process AI and then advancing this kind of domain knowledge, how we capture and distribute it, and the data enrichment to just automate a lot of the data labeling and data management tasks for people. Those are things that I'm super excited about for this year.
Wow, that seems like a really good list of uses of capital. And by the way, I am a huge fan of the website and the demo on the website. That was like the most beautiful interactive demo I've seen. You might as well like have given the product for free to someone. But I think that's gonna help a lot in onboarding new customers for sure.
It's new since today, so thank you.
Well, to close out, I just I want to end on a positive note, right? So, what are you looking forward to most this year?
I'm extremely excited about like the advancement that we're making on like those key pillars, like the process AI, the data enrichment, and the knowledge. Because I really think that those are going to be linchpins in how we make things in America. I really see a sea change in the industry because, like you brought up, like the American dynamism at the forefront, everyone now understands how important manufacturing is as an economic engine for the whole country and from like a national security perspective or just stability perspective. We all remember when we couldn't get stuff during the pandemic. And so just further like advancing manufacturing in a positive way in the national conversation is something I'm extremely excited about because not enough people know how rewarding and cool it is to work on really big industrial stuff. And I think it's one of the biggest joys in my life that I've been able to, attract amazing talent who otherwise wouldn't work on manufacturing, who now do. They love it and stay for a really long time. So there must be something to it.
I think there is something to it. Look, I had Chris Power from Hadrian on the podcast not too long ago, and he was like, look, people come in and they start working in a factory and they're like, oh my gosh, like this is real. Like this is real work. Like I'm doing something physical and you can see the output right in front of you.
Yeah.
So it's like a nice kind of, it's like a really satisfying way to work in a world where we're just glued to screens all the time and we don't see the physicality of it. So I think that there's a lot to come with that. And I think the manufacturing industry within the US is only just going to grow and become much more accretive for talent.
100%. And unfortunately, we don't have factories of our own, but we give everyone who starts steel-toe boots. And regardless of role, you have to go visit customers to understand who we're serving and why we're doing it. And we try to ensure that regardless of role, you go back frequently because that connection is what keeps people really excited and energized over the long haul.
Yeah, it's true. Well, thank you so much, Willem. This was a really fun conversation, and I'm so excited for you and your Series B. So congratulations again.
Thank you so much.